Okay, so what I'd like to do is just take a couple of minutes to go over the homework for lesson 10, particularly numbers 3 and 4. But let's start with number 1. Jeremiah has basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends one practice, and 2% of the time he does not attend either practice. What is X and what values does it take on? It wants to construct a probability distribution table like the one below. So basically we want to put in X, which is going to be how many times he attends practice in a week. And here's my answer in red, and that's 0, 1, or 2. And then what the probability of each of those days is. So it says 2% of the time he doesn't attend practice. So that would be 0.02. And then it says 8% of the time he attends one practice. So that would be 0.08. And then 90% of the time he attends both practices. So it's just a quick little probability table where you take the information that are given in words, or the information that is given in words, and you convert it to table form. And the reason that's important is you can work with it, which we will do when we get to number 4. Okay. Number 2, consider the given discrete probability function. Find the probability x is greater than 3. So if you're greater than 3, then you're either 4 or 5, and you need to add both of those up. So if 0.3 is the probability for 4 and 0.2 is the probability for 5, you add them both up and you get 0.5. When you guys do your homeworks, I don't look at every student's answer to every single question, but I do look through and get general trends for what questions might be giving difficulty and which ones seem to be pretty easy. And for the most part, this was an easy question on your homeworks. Everybody was rocking this. Okay, for number 3, and this one, not every person rocked, but just about every person rocked. So let's go through this and make sure you understand what they're looking for, because sometimes some students are confusing this with expected value. Let's be careful about what we read here. Last week you derived the probability distribution of the car sales sample, where a car dealer recorded the number of cars sold daily for 200 days. Don't worry about the last week stuff. I took the example out of a website. This is the number of cars sold daily, and they recorded this data over 200 days. The probability table is reproduced below. So this is the probability, and this right-hand column is the probability. And I think the thing that confused some students is this stuff about cars sold daily for 200 days. That's just where they got the data from. The 200 doesn't affect what the probability is. They could have done this over 100 days or over 900 days. They just used the data from those days to generate the table. It's the table that we're going to work with. So it says, what's the probability that x is 2, or probability 2? And it says right here in the table that that's 0.35. And then the probability of 3 is 0.25. And then it says the probability that it is greater than 2. If you are greater than 2, if you sell more than 2 cars in a day, then you've sold either 3 cars or 4 cars. If the probability of 3 cars is 0.25 and the probability of 4 cars is 0.20, then you add them up and you get a total probability for greater than 2 of 0.45. Okay? So it's all in the understanding of what the table is summarizing and what's telling you. What I saw on probably 3 or 4 papers is kids looking, maybe even 5 or 6 papers. I saw kids looking a little too deep, like there was more there. It really is that easy. What's the probability that x is 2? I look in the table. It's 0.35. What's the probability x is 3? I look in the table. It's 0.25. What's the probability that it's greater than 2? You know what? I do the same thing as in this question here. This one said greater than 3, but you added those two up, and everybody, I think just about everybody, got it right. It's the same exact procedure here in number 3.